Hey guys, I'm Talita. I'm a PhD student, and today we are going to talk about gradient methods for unconstrained optimization. And this is a small part from the session 4. And so, in that part, we are going to talk a little bit about steepest descent algorithm, and as also known as gradient descent. And well, is an optimization method that aims to find the minimal point of the function, as all the other method that we studied until now. And but now the central idea is to update the points towards the local minimum of the function. So let's start.
So the steepest descent algorithm, or just gradient descent, works in the same way as the direct search, but in that case we search along the line given by the following equation. And once again, k represents the kth iteration of the algorithm, and we find the value alpha that minimize the function fx, and so we update our new estimate of the minimum, and then we repeat the process until the solution converges. And in that case here, the convergence is given by these either conditions, epsilon 1 and epsilon 2. And in the later case, if the gradient is very small, then you effectively no longer descending. Okay, let's see this first example. So we want to minimize this function fx, where x is our vector and we have two variables, x1 and x2, and also our starting point, it's the x0, that it's 1 and 1, and this starting point, it's like a initial guess. Okay, so first we need to determine the gradient at the starting point, and here we have our first equation, our first form for the gradient, that it's x2 plus 2x1 and x1 plus 4x2. Okay, so now we replace the x0, our starting point, at x2 and x1, or in that case we have that x2 and x1 it's equal 1. So for this we have that the gradient of our function at the starting point is 3 and 5. So now we start our search line, our new search, given by this equation, where x1 is equal x0 minus alpha gradient f x0. So in that case, we have the value for x1 equal our x0, that in that case it's 1 1, and we got the equation 1 minus 3 alpha and 1 minus 5 alpha. Well, so now we create a function with alpha, so f alpha, and we replace x1 at the original function fx. So in that case, we got the result for f alpha like. In that case, if we look for the original function, uh, and we look for the x1, so the first line is for x1 and the second line is for x2. So we replace this value in function of alpha in our original function. So we got this equation, and then now we need to find a alpha that minimize this function. So from the first derivative, we can get a value for alpha that it's equal 0.2297297. And if we just look put this alpha in our function. We are got this value for alpha, and we wanna check if this is a minimum. So for this, we look for the second derivative, and if it's greater than 0, so we have a minimum. In that case, it's positive, so it's greater than 0, so our alpha, it's a minimum for our first function. So in that way, we have our value for x1, so we can just replace the value that we find for alpha in our function. So we got that for our first iteration, our vector x got the values 0.3 and minus 0.14. So, okay, this was for the first iteration. Now we need to do the same way, considering like x1. Now it's our starting point. So now we have a new value for the gradient when we are considering our starting point as the value for x from our first iteration. And now we need to do a new sort line where x2 is equal x1 minus alpha gradient of fx1. So we just need to replace all the values, and
So
we got
we
this
got
new equation
these
for
new
x2 that
equations
depends of
for
alpha.
the
So
second
now we need to
iteration,
find a new
and
alpha
now we need
that
to find a
minimize
new
this
alpha
equation
that
when we are
minimize our
considering
function.
now the x2.
But in that case, now
So
we are
we
going to
do the
use the
same way
x2.
again
So for that,
to find
we
the equation
find
for
this new alpha
f alpha,
using the first
and then
derivative
we
as the
find the alpha
same
like
step. And
equals zero point
you also
0.6,
check that if it's a
and if
minimum,
we
so
check
yeah, it's a minimum.
our second
And
derivative,
in that
we are
case
gonna see
here,
that it's a
we can see
minimum as
that we are
well, and
really
we are
close
really close to
to
0 now.
0. So finally, we can find our x2. So it's just replace the value of alpha in our previous equation. So in that case here, we have that our final value for our two iterations is 0.02 and 0.02. So here, if we simulate this problem in MATLAB, so we are gonna get this contour graph. So here, this faraway point is x0, and then we get closer with x1, and then more closer to 0, so the minimum with x2. So now let's do again with the same function, but we're gonna change our initial guess. Our starting point now it's a negative, so it's -1 and -1. So for the letter A, we need to get our gradient in the same way we get the derivative. So we have the same function because we have the same original function. So here we have the same gradient. What's gonna change, it's now that we need to replace our x2 and x1 for x0. In that case, it's -1. So here our gradient now it's gonna be -3 and -5. So now we need to calculate our vector x for the first interaction, x1. So we need to replace x0, that it's our initial guess, as -1, -1, and our gradient of f x0, -3 and -5. So we got the two equations for x1 and x2, the two variables, -1, -3 alpha, and -1, -5 alpha. Okay, now we want to find alpha that minimize our function f alpha. So for the first interaction, so x for the first line it's our variable x1, and the second line it's our variable x2. So we got these equations and replace in our original function, and that way we can just find our function for alpha.
Again, we do the first derivative and to find our alpha, and the second derivative is to check if this value of alpha is a minimum for our function. So as it's greater than 0, so yeah, it's a minimum. So now with this value we can finally get our new point x1, our vector x for our first iteration. That way, the x for the first iteration is 1 1 minus 3 alpha and minus 1 minus 5 alpha. And then we are going to get the value for alpha that we find in the letter C and replace here in our equation. So finally we get the new point x1, it's minus 1.6 and minus 2.1.